So this class is about transpiration, which is a movement of water from the soil through a plant and into the atmosphere. So basically the roots take up water from the soil and the water is drawn up the stem to the leaves, and water then evaporates from the leaves. So there's a continuous movement, which is called the transpiration stream. So the objectives we're going to look at is explain the ascent of water in plants and discuss the impact of environmental factors on the rate of transpiration. And in order to do this, we need to look at root pressure, capillarity, cohesion, adhesion, and transpiration pull, and include the role of stomata. To look at it, then the movement of water through plants' xylem is largely due to evaporation of water vapor from the leaves and the cohesive and adhesive properties exhibited by water molecules. And for cohesion, water molecules' tendency to stick together, and adhesion, sticking to the walls of the xylem vessel. And this basically explains why water moves up the xylem vessel. Adhesion, water by capillary action, will move up the xylem vessel, but also the movement of water. As water moves up, it pulls other water molecules with it. And it is a gradient of water potential that is a driving force, permitting the movement of water from the soil, where the water potential is high, to the atmosphere, where the water potential is low, via the plant cells. And plant cells are taking water in at their roots and losing it via stomata. So water loss occurs through stomata. And the stomata are there really for photosynthesis, so that carbon dioxide can enter, but it also allows water to leave. And around 99% of the water absorbed is lost through evaporation from the plant stem and its leaves in a process called transpiration. And transpiration refers to loss of water vapor from a plant to its environment by diffusion, and the transpiration stream refers to movement of water from the root to the leaves. So a continuous movement of water going from the root to the leaves, and this is called the transpiration stream. And the advantage of transpiration is that it provides a means of cooling the plant via evaporative cooling. And transpiration stream is helpful in the uptake of mineral ions. And the turgor pressure of the cells, due to the presence of water that moves up the plant, provides support for leaves, increasing the surface area of the leaf blade. So keeping a leaf turgid helps the plant to photosynthesize. Now, movement of water through leaves. Certain environmental conditions, such as high humidity, high temperature, can cause a water potential gradient between the air and the leaves. And inside of the leaves, you have a high water potential, and outside, you have a lower water potential. And remember, water moves from high potential to low potential. The water vapor lost by transpiration lowers the water potential of the air spaces surrounding the mesophyll cells. So more water will be drawn up, therefore. The water potential of the mesophyll cells evaporates into the air spaces, resulting in a transpiration pull. Remember, the water molecules are cohesive, and as one moves away, it's going to pull other water molecules with it. The transpiration pull results in movement of water through mesophyll cell walls, which is an apoplastic pathway, which we discussed in the previous class, or the mesophyll cytoplasm into the cell wall, and the pull from water moving from the mesophyll cells results in water leaving the xylem vessels through pits, which are non-lignified areas, which then cause water to move up xylem vessels due to the cohesive properties of water. And as I said, this is called the transpiration stream. And the role of the stomata. Transpiration is mainly controlled by pairs of guard cells that surround stomata. So the stomata will control water movement. Guard cells open when stomata are turgid, and close when they are flaccid, i.e. when they lose water. And when stomata are open, there is a greater rate of transpiration and of gaseous exchange. When stomata close, transpiration and gaseous exchange decrease, so photosynthesis will fall as well. As stomata allow gaseous exchange, carbon dioxide in and oxygen out, they are generally open during the daytime. There are some plants which can have their stomata open at night time. This is called crassulation acid metabolism. And basically, during the night time, they absorb carbon dioxide, which can then be used during the day for photosynthesis. Of course, the carbon dioxide isn't fixed at this point, but will be fixed later on. And then water diffuses with stomata to the atmosphere. This causes a lowering of the water potential of the air spaces in the leaf, and more water molecules in the surrounding mesophyll consequently evaporate, creating a transpiration pull. Then water moves through mesophyll cells through both apoplastic and symplastic pathways. And water leaves xylem vessels through non-lignified areas, and water moves up a xylem vessel. So again, we can see the apoplastic pathway and the symplastic pathway for the movement of water going out of a cell. And notice it goes through stomata with an open guard cell and goes from a vascular bundle with the xylem vessels. And transpiration pull is a consequence of the cohesion between water molecules. So the water molecules are pulled up as water evaporates from the mesophyll cells in the leaf. However, water molecules can also move up xylem vessels when the rates of transpiration are low. This is a consequence of root pressure, which is a consequence of lower water potential at the base of the xylem vessel compared with the surrounding tissue. So therefore, water will enter the base of the xylem vessel, and water will move up, and therefore it exerts a pressure, and this pressure is called root pressure. So root pressure is a consequence of the lower water potential at the base of the xylem vessel. So water will enter, causing what is called a hydrostatic pressure. Then, factors affecting the rate of transpiration. Light. Transpiration increases in bright light. The stomata open wider, which allows more carbon dioxide to enter the leaf for photosynthesis, and more water is therefore able to evaporate. The next one is temperature. Transpiration is faster in higher temperatures, and evaporation and diffusion are faster at higher temperatures. So that's important. At higher temperatures, both evaporation and diffusion are faster. Remember, plants photosynthesize faster at warmer temperatures, largely as a consequence of higher rates of diffusion. Then wind. Transpiration is fast in windy conditions, as water vapor is removed quickly by air movement, speeding up the diffusion, really because the water potential difference is greater. And humidity, which slows down the rate of transpiration. So diffusion of water out of the leaf slows down. because the atmosphere is already moist. And the rate of transpiration can be measured using what is called a potometer. And this structure here is called a potometer, where you have a leafy shoot and some apparatus. And you have a bubble in the apparatus. And you measure the rate at which this bubble moves along the scale. If it moves the end of the scale, you can turn this tap to let water back into the apparatus and push the bubble back to the starting position. And of course, water is continually moving up here because it's important to have water on both on this side of the bubble and that side of the bubble. And you can return it to the beginning this way. And of course, the apparatus needs to be airtight. And this again is another picture of the potometer. And there's a information on the potometer here.